A traditional residential architecture firm producing a full property portfolio, 20 unit types, 3 exterior schemes, full documentation, needs roughly 8 people and 12 weeks. A developer's team using a properly configured generative design and AI agent pipeline can produce the same scope with 1 architect in 2 weeks. Not a different quality of output, the same output with fewer people in less time. Autodesk's research on generative design workflows documents iteration speed gains of 3 to 10 times versus manual CAD on equivalent design problems. That multiplier is what this video is about, where it comes from, how the pipeline is actually built, and the 3 cases where you still need a licensed human at the drafting table. McKinsey Global Institute's construction productivity research is one of the most cited datasets in the industry. Construction productivity grew less than 1% per year for 2 decades, making it one of the worst performing sectors in the global economy. The bottleneck was never the building, it was the design and documentation pipeline. Every iteration of a floor plan required a drafter. Every zoning change required a permit package resubmission. Every site option required a feasibility study that took weeks. Generative design changes that equation because it moves iteration from human hours to compute minutes. The RIBA AI in Practice survey found that 42% of architecture firms are now using AI in their design workflow, and 67% of those report time savings above 30%. Deloitte's AI in Real Estate report puts pre-permit documentation time reduction at 40 to 60% with AI-assisted workflows. The shift is not coming. It is already in production at a significant share of mid-size and large firms. Let's define it clearly. A generative design and AI agent stack for real estate is a pipeline that does 4 things. 1. It takes a design brief, site dimensions, zoning constraints, target unit mix, budget envelope, and autonomously generates multiple compliant design options, not one. Autodesk Forma, for example, generates dozens of massing options from a site boundary and constraint set in minutes. 2. It evaluates each option against real performance criteria: daylight hours, floor area ratio, energy load estimate, construction cost estimate, using simulation models without a human running each simulation manually. 3. It selects or ranks the top options against the developer's priority weights and produces a rationalized recommendation with supporting evidence. 4. It generates the downstream documentation, floor plan drawings, area schedules, preliminary permit packages, directly from the selected design without redrafting. The result is a pipeline where the architect's creative judgment is applied at the brief and at the final selection, and the compute handles every step in between. That is what removes the 8-person team. The technical architecture has 4 layers. Layer 1 is the parametric design engine. This is software, Autodesk Forma, Rhino with Grasshopper, or a custom Python-based geometry library that takes the design constraints as structured inputs and generates geometry programmatically. The key property is that the geometry is parametric, meaning every element is a function of its inputs, not a fixed drawing. Change the setback and every unit, every corridor, every facade updates automatically. Layer 2 is the simulation layer. For each generated option, the stack runs parallel simulations: daylight and solar analysis, structural pre-check, energy model, and a cost estimate from a quantity takeoff. These used to require specialist consultants for each. Today they run as automated API calls to services like Ladybug tools for energy, or cost estimation APIs that price from area and material specifications. Layer 3 is the LLM agent. A large language model, typically GPT-4o or Claude, receives the brief, the simulation results, and the developer's stated priorities, and produces a ranked recommendation with natural language justification. This is the layer that translates numbers into decisions. Layer 4 is the document generation layer. From the selected design, the stack generates permit-ready drawings in the required format, area schedules in spreadsheet form, and a project summary document. Tools like Speckle handle the data handoff between design and documentation systems. End-to-end, what used to take 12 weeks of human iteration takes 2 to 3 weeks of configured pipeline time, with human review at the brief, at the selection, and at the permit submission. AEC Tech community benchmarks put feasibility study time reduction at 80% on comparable projects. 5 specific points where traditional design workflows lose to a generative AI pipeline. Point 1. Iteration count. A traditional firm produces 3 to 5 design options for a site in a feasibility study. A generative pipeline produces 50 to 200, evaluating each against the same performance criteria. More options means a higher probability of finding the optimal solution, not just a good enough one. McKinsey's research on complex design problems documents that expanding the explored option space by 10 times improves final outcome quality by 20 to 30%. Point 2. Simulation speed. Running a daylight analysis manually on a single design option takes a specialist half a day. The same analysis as an automated API call in a generative pipeline takes 4 minutes. Multiply that across 50 options and the math is obvious. Point 3. Documentation consistency. In a traditional workflow, when a design changes after the permit package is submitted, someone redraws the affected sheets manually, and errors creep in. In a generative pipeline, the drawings are generated from the model, so a design change propagates automatically to every affected document. Deloitte puts documentation error rates at 60% lower in AI-assisted workflows versus manual. Point 4. Zoning compliance checking. Every jurisdiction has its own zoning rules, setbacks, height limits, FAR, parking ratios. Checking a design against all applicable rules manually takes days. A compliance checking layer in a generative pipeline runs the same check in minutes, flagging every violation with its code reference. Point 5. Cost estimation accuracy. Traditional early-stage cost estimates based on square footage rules of thumb are off by 20 to 40%. Generative pipelines that run quantity takeoffs from actual geometry produce estimates accurate to within 10 to 15% at the same design stage, documented in AEC Tech industry benchmarks. Let me put numbers from cited sources in a table. First metric, design iteration speed. Traditional workflow produces 3 to 5 options per feasibility study. Generative AI pipeline produces 50 to 200. Source, Autodesk Generative Design Research. Second metric, simulation time per design option. Traditional half a day for daylight analysis. Generative pipeline 4 to 8 minutes. Source, AEC Tech community benchmarks. Third metric, pre-permit documentation time. Traditional 8 to 12 weeks for a full permit package. With AI-assisted documentation, 3 to 5 weeks. Source, Deloitte AI in real estate. Fourth metric, documentation error rate. Traditional workflow baseline. AI-assisted, 60% lower rate of intersheet inconsistencies. Source, Deloitte. Fifth metric, early-stage cost estimate accuracy. Traditional rule of thumb, plus or minus 20 to 40%. Generative with quantity takeoff, plus or minus 10 to 15% at the same stage. Source, AEC Tech. Sixth metric, overall project delivery time, design through permit approval. Traditional for a mid-size multifamily project, 14 to 18 months. With generative design pipeline, 9 to 12 months. Source, McKinsey Construction Productivity Research. Seventh metric, adoption rate among architecture firms using AI in active projects. 42% as of the most recent RIBA survey, up from 11% 2 years prior. Now, I want to be precise about what these numbers mean. The pipeline does not replace the architect. It replaces the hours spent on tasks that do not require architectural judgment, drafting, simulation runs, compliance checking, documentation formatting. The architect's time shifts to the brief, the selection, and the client conversation. That is a better use of an architect's license. Picture a residential developer working on a multifamily infill site in an urban market. 60 units, 5 stories, mixed income zoning requirements. Before a generative design pipeline, the developer engages an architecture firm. 8 weeks of schematic design produce 3 massing options. Each option requires manual daylight simulations, 3 weeks of consultant time. Cost estimates from the quantity surveyor take 2 more weeks. Total feasibility study, 13 weeks, involving 11 people across 4 firms. Only one option advances to design development, and it is not necessarily the highest performing one. It is the one the team liked best visually. After, the developer uses a properly configured generative design stack. In week 1, the parametric engine generates 84 compliant massing options from the site constraints and zoning envelope. In week 2, automated simulations run daylight, energy, FAR, and construction cost estimate on all 84 options in parallel. The LLM agent ranks them against the developer's stated priorities: maximize rentable area, minimize structural complexity, meet daylight requirements, and produces a ranked list with supporting analysis. The developer reviews the top 5 with the architect, selects one, and the documentation layer generates the schematic permit package. Total feasibility study, 3 weeks, 1 architect, 1 developer, 1 subscription to the tool stack. The selected design ranks in the top 3% of the 84 options on every performance metric simultaneously, something a 3-option manual study almost certainly would not find. That is the unit economics of expanding the option space with compute instead of headcount. 3 cases where generative design does not win and you need a licensed human making the call. Case 1. Culturally or historically sensitive sites. When a building must respond to its urban context in a way that requires architectural interpretation. A heritage street, a civic landmark adjacency, a site with specific cultural meaning. Generative tools optimize for measurable parameters. They cannot optimize for, this building should feel like it belongs here in 50 years. That judgment is irreducibly human. Case 2. Novel structural systems. Generative pipelines check structural pre-compliance against standard systems. If the project requires an engineered structural solution that does not fit the tool's library, long-span timber, innovative seismic isolation, a complex foundation condition, the structural engineer's judgment takes precedence over any automated check. Case 3. Permit authority discretion. In many jurisdictions, planning approvals involve a discretionary hearing where a human planning commissioner makes a judgment call that is not fully rule-based. No generative tool can model what a planning commission will approve at a specific political moment. The human architect who has appeared before that commission and who understands the political and contextual dynamics remains the critical variable. So the honest recommendation is, use generative design to find the highest performing option in the constrained parameter space, and then use human judgment to decide whether that option is also the right option for the site, the community, and the approval process. 4 steps to start using a generative design pipeline on your next project without buying new enterprise software. Step 1. Pick one parameter to automate first. Do not try to automate the whole design pipeline at once. Pick one repetitive step, floor plate layout optimization, daylight simulation, or zoning compliance check, and automate only that. Step 2. Use the tools that already exist in your stack. If your firm uses Rhino, Grasshopper already provides parametric design capability. If you use Revit, Dynamo does the same. If you use Autodesk Forma, the generative massing tools are built in. You probably do not need to buy new software. Step 3. Connect one simulation API. Ladybug Tools for Daylight and Energy runs locally and is open source. Building cost APIs like Destiny or CostX have free tiers. Connect one, automate one simulation type, run it on your next project in parallel with the manual workflow, and compare the results. Step 4. Treat the AI agent as a junior analyst, not a designer. Give it the brief, the simulation results, and the constraints. Ask it to rank and justify. Review its output the way you would review an analyst's memo, with your own judgment on top. Quick recap. Generative design AI gives you 50 to 200 design options where manual workflows give you 3 to 5. Simulations that took days take minutes. Documentation that took months takes weeks. Autodesk, McKinsey, RIBA, and Deloitte all document the same direction. And the human architect still owns cultural context, novel structure, and the planning commission. If this breakdown is useful, subscribe. Next week, the topic is automating after-hours lead qualification with custom AI voice agents.